So here's an interesting math problem that I want to show the way that I approached it. It's not the only way, but it's a way to do this. So here we go. The gist of it is we have this large circle, and we have these arcs that are made from circles that are the same radius as the large circle. Then we have this smaller circle that's concentric to the large circle that is tangent to each of these arcs. And what we need to figure out is the area of the shaded region and the perimeter of it. Okay, so that being said, let's get started. So the first time I approached this, I thought, well, let me connect these intersections together to make this square and see if I can't do this without having to find the area of the segments individually. And I was successful. So here's what happened. I took, and I'm trying to find the area of all of this at once. Okay. And so what I did was I took the circle, and I found the area of the big circle, and then I found the length of one of the sides of the square by connecting the center to these intersections. So this made a isosceles right triangle, and so I knew using the radius here that the sides of this triangle are both 3. Well, I'm going to leave out the numbers for the rest of this, but yeah. So you know that the radius of the circle is the sides of these triangles. So you can use that to figure out the area of the square. You take the area of the big circle and subtract the area of the square to get what I've shaded already. Now, the parts of the arc that I haven't shaded are congruent to the parts that I have, so you can just double that to figure out the whole shaded area in here. So all of the yellow shaded parts I found just by doubling that. Now that's not the part we're trying to find, but it does help me get closer. What that does help me find is this entire middle part in here. So I can take and subtract what I just got from the big circle to find the area of the blue part right in there. Okay, so then all I have to do is subtract the area of the little circle, which can seem kind of confusing. How do you figure out the radius of that little circle? So let me take out all this extra stuff and approach that part of it. So what I want to do is I'm going to imagine that one of these big circles is out here on the outside. All right, and so we've got this tangent line that goes to the center of the circle and goes to the center of my little circle there. Okay, and I can use this information to figure out the radius of that little circle, because I know the radius of these circles, so that's going to be the same. So I can figure out the hypotenuse here, and then from that hypotenuse I'm going to subtract the radius of that circle. Okay, and that will give me that amount right there. Alright, so the last part of this was talking about the perimeter of this shaded area. Okay, so it should be pretty easy to figure out the perimeter on the inside there. But for the other part, let me make another little illustration to help out. So I've got, I'm going to quickly get me a visual aid here. So as I take this and I go around the circle, you should notice something. All right. Well, I hope that helps. Feel free to give me any questions you got, and have a good one.